So everyone, we are recording now, and I'm going to keep, I'm going to try staying on the chat window. So today, instead of, I'll still have you all work several problems and give you the minute and a half like I did last week, but also some of them we'll kind of work through together, and you all feel free to kind of chat at me while we're going through it. And so I usually like to get people involved. I don't like to just do the problems. And so I'll ask some questions along the way, and then those of you all that want to kind of chat to me, we might be able to get through some of the problems a little faster so that we're not I know we went over a few minutes last week, so I'll try to stay right on time today. And feel free, like I said, we'll record this, so if you do have to leave a little early, I won't be offended. So I know everybody has a lot going on. So.
And I just want to check really quickly. I sent out the materials. You either received it from me or you received it from Wanda Wolcott. It should have said Praxis materials for part 2 or something like that. I just put it in the chat part of the group. So if you did not receive it, it is there. Something that I know, I put it in the email that was sent out also, something that helps you to be able to access everything is if you sign in to an account with Teams, you can create an account if you don't have a card mail just yet, because I know some people haven't started at U of L yet, but they plan to come. You should be able to sign in or create an account. So just make sure you create an account, because if Jonathan tries to use the whiteboard today, you might not be able to see it. And also,
I'll continue to use the paint again. That seems to work. I think everyone could see it. Yeah.
Okay, and then you won't be able to see anything that we put in the group. Like if I put a PDF file, you might not be able to see it. If you cannot see it, just write in the message, just say, hey, can you send me the materials? And then I'm watching it. Even though I'm muted, I'll be sending emails to anybody who needs access to it. And one more question. Anybody who attended the part 1 Praxis workshop, were you all able to see the recording? Was anyone able to access the recording? No? Okay. We're working on that, so we'll get it. Brenda, you're on mute if it was Miss Brenda.
Okay, you asked me I'm sorry, you said was I able to see the recording what Jonathan was doing?
Yes.
Yeah.
Oh, so you can watch it. So some people can watch it and some people can't.
Yeah.
So we're going to figure that out.
Yeah, I saw everything that he was doing with the link that you sent directly to me.
Okay.
So I signed in late.
Okay, thank you, Miss Brenda.
All right.
I'll send something else out. We're trying to figure out another way to navigate it because everyone can't access it for some reason. So I'll work that out and hopefully we'll have it to you all. Hopefully today. If not today, then I'm hoping Monday we'll have it figured out. So, all right, Jonathan, that's all I have.
Sounds great. All right, we'll hop in then and get started. Let me share my screen here. Oh, you don't need that. Let's see. Here we go. All right, so just real quickly, kind of go over our plan for today. Kind of go back over the exam. For anybody that wasn't here last week, I'll just quickly review the exam. And then today we're going to focus on algebra and geometry type questions. And so we'll kind of go over some formulas to know. There are some formulas they'll expect you to know on the Praxis, and so we'll talk about those. I'll give you some homework that you could be working on before you take the Praxis, and then give you a few closing thoughts. And I've always got to throw in some pictures of my kids, right? So there's actually them smiling and acting like they like each other. Okay, so the exam. Remember, there is a possibility that you could take the old or the new version of the Praxis core, and so the old version was 85 minutes to complete 56 questions. It's about a minute and a half per question. There are multiple choice selected response, which means you can mark more than one, and a few short answer questions, which short answer for math just means you have to type in the answer. It's not like you have to write a paragraph or anything. You will have an on-screen calculator, but as you'll notice, it's pretty basic. And the test will have number and quantity type questions. We did those last week, and the statistics and probability. So we kind of looked at a bunch of those last week. That makes up, again, 30% for number and quantity, 20% for probability and statistics, about 30% geometry, or sorry, algebra, and about 20% geometry. So that's the old version of the test. The new version, they give you 5 extra minutes to do the same number of problems, but everything else is the same there. And in terms of the content, there's fewer algebra and geometry questions on the new version and more data, statistics, and probability. So yeah. All right, so if everybody can check and make sure, let me jump out for just a second. So we've got a couple of people maybe that aren't muted, and so we're hearing a lot of kind of background noise. Hey, I think you took care of it yourself. Thank you. Okay, hop back in here. Okay. So last week, again, we looked at number and quantity, statistics and probability. This week, algebra and geometry. And let's go ahead and jump in and look at a few problems. And like I said, I'll be kind of popping in and out of the PowerPoint so that I can read the chat messages. So first of all, with algebra and functions, some of the topics include simplifying expressions. So this is where you can use the distributive property a lot of times and combining like terms, working with expressions and equations, solving linear equations and inequalities, working with functions, solving problems that have ratios and proportions, looking at linear equations and their graphs, interpreting graphs, understanding word problems. I know a lot of this, it may be so long since you've seen some of these algebra that this may not mean a whole lot, but we're going to look at examples that involve pretty much all of these ideas now. So let's go ahead and jump in. Now I know that we may be all over the place in terms of how comfortable we are with algebra, and so I'm going to look at kind of a pretty basic one with you to begin with. So the first one is solve the following linear equation: 3x minus 9 equals 12. So 3x minus 9 equals 12. So just to make sure that we're kind of on the same page here, let me pull up Paint for a minute. Okay, so we have 3x minus 9 equals 12. So if I ask you to solve, then what we're trying to do is we're trying to isolate x. We want to get x by itself. So we have 3x minus 9 equals 12. So if we have this minus 9 here, we want to move it to the other side because we're trying to get x by itself. And so if we have a minus 9, we can move it using the inverse operation. So addition and subtraction are inverses, multiplication and division are inverses. So a negative 9 plus 9 is 0. So you could think of that as kind of canceling out. So all we're left with on the left-hand side is 3x. And then on the right-hand side, we have 12 plus 9 is 21. All right, so because of the minus 9 here, we added 9 to both sides. That canceled this out, and we're left with 3x equals 21. Now, if you see a 3 and an x side by side, that means that you multiply them. So this is multiplication, so the inverse operation will be division. So we're going to divide both sides by 3, because again, we're trying to get x isolated. 3 divided by 3 is 1. And so 1x is just x. So now we just have x. 21 divided by 3 is 7. So we added 9 to both sides. We divided 3 on both sides. And then we're left with just x, which is what we wanted, equals 7, which is choice B as in boy. So I'll leave this here and take about 1 minute and try the follow-up exercise that you have there. It's 1 over 5x plus 4 equals a negative 6. So I'll give you a second there to play with that. 1/5 x plus 4 equals negative 6.
Is that on the slide, Jonathan? I'm still seeing the PowerPoint. I mean, I'm still.
Oh, you're not seeing Paint?
I guess I am seeing Paint. I'm confused. Just ignore me.
Are you seeing my work where I've written?
Yes.
Okay.
Was that that's in the little box, wasn't it? The 1/5 x plus 4 in the box. Okay.
Yes. Yeah. Sorry if you don't have the handout. Sorry, I was assuming everyone has the handout. If you don't have the handout, the problem that I'm asking you to try is 1/5 x plus 4. So this is on the handout if you actually have a copy of the handout, equals a negative 6.
And if you don't have the handout, please message me, message the group and say I don't have it. I did put the handout in the group just in case someone didn't receive it.
And then when I'm in share screen mode, Wanda or Sherry, I can't actually see the text message. So instead of popping in and out, feel free if you all want to share, like if people are texting in what they're getting for the answers or letting me know that they're, feel free to let me know if you see some stuff in there that we need to talk about.
Will do.
Will do.
Okay, so let's go ahead for the sake of time. Again, I'm going to try to keep us moving today. So 1/5 x plus 4 equals a -6. So again, we're going to do inverse operations. One thing I didn't mention here is that we're going to do addition and subtraction first before we do multiplication and division. And so we'll always start kind of with the addition and subtraction piece. So here we're going to subtract 4 on both sides because 4 minus 4 is 0. So we're left with 1/5 x on the left-hand side. And then a -4 minus 4, or sorry, -6 minus 4 is -10. Remember, you will have access to a basic calculator. So if you have trouble adding and subtracting integers, which include negative numbers, you will be able to use a calculator. But again, it doesn't hurt. You can think of this as being, if you're in the hole 6 and you go down in the hole 4 more, you're now 10 in the hole. And so it's -10. All right, so 1/5. So you could think of 1/5 x is the same thing as x divided by 5. And so you could even write it if you wanted to as x over 5, x divided by 5. Or you could leave it as 1/5 x. But the important thing is that you know that if you have like a 1/5 or x divided by 5, that our inverse operation is going to be to multiply both sides by 5. So we're going to multiply both sides by 5. 5 divided by 5 is 1, so that cancels out and just leaves it x. -10 times 5 is -50. So the answer is -50. So I'll leave that up for just a second. And then okay, so -50 on that one. Any questions? Looks like I'm seeing a lot of -50s in the box. So that's good. If you got a +50, no worries, you just lost your negative somewhere along the way. So watch that. The multiple choice answers are pretty bad about always putting the positive and negative in case you do lose that. So yeah, so just watch for that. Okay, so I'll hop back into the PowerPoint. Okay. The next one says Marcus purchases a video game with a price tag of $D. If the sales tax on the item is 6%, which expression represents the final cost of the game? So we're looking for the final price. We know that the game costs $D and sales tax on the item is 6%. So which represents the final cost of the game? Is it A, B, C, D, or E? I'll give you a second, and then so Wanda and Sherry, if one of you all could just let me know as answers start coming in, and we'll talk through it.
I see a couple D's.
Okay, a couple of D's.
Mm-hmm.
Any other choices except for D? So D is the correct answer. So let's kind of look through the answer choices. So answer A, what that's giving you is just the sales tax, right? And you all know this from kind of working in the real world. If you're going to buy something that costs a certain amount, you multiply it by 0.06 and that will tell you the sales tax, right? So if the problem had said which expression represents the sales tax, then we would have chosen A. Now, a lot of times students will choose choice B because they'll see the price plus 0.06. That only adds 6 cents. That doesn't actually add 6% of the total price. And so B is close, but again, you need to multiply the 6% times however much the item cost. It's not going to be a flat 6 cents, obviously. C and E don't really work in this case because we're adding sales tax. We're not subtracting an amount. So it is going to be choice D as in dog. Good. All right. And so in this case, again, one of my test tips, if you need to always make an educated guess. And so again, here, in terms of an educated guess, you could probably eliminate C and E pretty quickly because we're talking about sales tax and we don't subtract an amount whenever we're adding on sales tax. So it's probably going to be, you know, choice B or D, just thinking about the fact that sales tax includes adding an amount. Okay, so I'll
Jonathan,
give you,
I've raised
yes.
my hand. I have a quick
Okay.
question.
Tell
You
me.
said make an educated, it's Wanda. You said make an educated guess. So
Yeah.
I'm confused. Do they need to, I thought if you didn't know, you left it alone. So should you always
So
answer?
eventually you'll need to make a guess on all of them. You're not penalized for guessing.
Thank you.
Yeah, on some tests you're penalized for making a guess, and they recommend that you leave it blank, but there's no penalty for guessing on the Praxis core. And so yeah, you'll definitely at some point, if you're not sure, you just want to make your best guess. Good question. Yeah. Okay, so I'm going to give you a minute and a half on this one. Which of the functions below will produce the table of values shown? So you'll see a table there with the x values and the f of x values. Even if you don't really know what f of x means, play around with it for a minute and see what you can do there. And I'll give you about a minute and a half.
It looks like we got 1E, 1E,
Yeah, we have several E's, Jonathan. We got a B.
Okay. Okay, so on this one, so what you're doing here is you want to plug in these values of x into the formulas and then see what you're getting for this f of x. So did you say, Wanda, you were saying a B?
Yes.
So if you plug a 1 in for x, so if you plug a 1 into this formula, 1 plus 2 equals 3. And so for 1, if we got a 3 here, it would be choice B. But when we plug in a 1, we get 1. So we have to kind of watch and see which one of these will actually make that happen. So B, and you said also E was another one?
Yes.
So let's try E.
yes, yeah.
Okay, so let's try it. 2x minus 1. So let me go back over to Paint. So we've got x, and then we have f of x, which f just stands for function. So if the function's 2x minus 1, okay, so if I plug in a 1 for x, so if I substitute in a 1 here and a 1 here, so the function evaluated at 1 gives us 2 times 1, which is 2, minus 1, which is 1. So far, so good. You plug a 2 in. So if we substitute in a 2, the function evaluated at 2, we get 2 times 2 is 4, minus 1 is 3. Let's try a 3. If we substitute in a 3, the function evaluated at 3, 2 times 3 is 6, minus 1 is 5. So that seems to be doing it. So it is going to be choice E, and the best way to kind of look at that is to actually just try plugging in the different values of x, substituting those in and seeing what you get then for the function values. Okay. So choice E is an Edward. All right, which of the following expressions is equivalent to -3 times the quantity of x minus 5 minus the quantity 2 minus x? So I'll give you about a minute to see if you can find out which of these expressions is equivalent. So we need to simplify here. Take about a minute.
We got 2 D's.
Okay. Anything else other than D?
Not quite yet.
Okay.
1 E.
Okay. Okay, so let's go ahead and kind of talk through. So D and E seem to be the consensus so far. So this is where we're going to use what's called the distributive property. So we have -3, and then with the parentheses here, that's going to tell us that we're going to multiply this in. And so a -3 times a positive x is a -3x. Negative times a negative is a positive, so -3 times a -5, positive 15. Now, here, and if you ended up getting answer E, I think what happened was that you probably then multiplied this times this, but we have this minus between them. And so actually all we're going to do is distribute in, you can think of it as kind of distributing in this negative or distributing in a -1. So -1 times 2 would be -2 or -2, and negative times a negative is a positive x. So we have -3x plus 15, and then here we're kind of distributing in this negative, so -2, and then don't forget to distribute here and make this a positive x. Now we can combine like terms. So if you'll notice, when we say like terms, all the terms that have an x, we can combine them, and then the terms that are constants here, we can combine them. So -3x plus 1x, because if you just have an x by itself, it's 1. So -3 plus 1 is -2. So -3x plus 1x is -2x. And then positive 15 minus 2 is a positive 13, which is choice D, as in dog. All right, so I'll leave that for just a minute. And then we've done the first group of 4, so there's 12 algebra problems. So I'll stop after each group of 4, and if there's some questions that you want to ask. And so let's go ahead and hop out, and feel free to throw something into the text, or if you have any questions, feel free.
What are the key terms, Dr. Watson, that we should be looking for in knowing which process or function to use in algebra? Like, what's the key?
That's a good question. Yeah, so usually, like, if you see the word solve, solve's a big one. So that's going to mean that you're trying to usually get some kind of variable by itself. So like the first problem we did said solve for x. That just means get x by itself. A lot of times, another word that you'll see a lot is going to be simplify. So that's what we just did in the last problem, is that we combined, use the distributive property, we combined like terms, but we didn't actually get an answer like x equals 3 on that last problem because it wasn't an equation, that there wasn't like an equal sign involved. So on that one, all we could do is just simplify or just combine things. So a lot of times it's either going to be like simplifying or solving, and those will be what you're looking for. And if you're kind of stuck on where to go, especially on this kind of test when it's multiple choice, it's nice if you look at the answer choices, you can get kind of an idea of like, is the goal here to get an answer like x equals 5, or is the answer to just combine things together? And so, but those are two of the big ones. And then I'll give you some formulas later too to know. But on a lot of these algebra problems, it's either going to be like a simplify or a solve type problem. Good question. Brenda, did you have a question?
Jonathan, I missed number 3. I had to step away for a second. Which
No problem.
one was it?
E is in Edward.
E was in it. Okay, I just want to make sure. Okay, thank you.
No problem. Other questions?
Mute.
Okay, let's hop in then. So next one's going to be 5. So I'll give you a minute to play with this one. So this is going to be one where we're going to kind of substitute values in. And so on this one, it's if 2/3. Oh, let me go ahead and share. Sorry for those of you all that don't have the handout.
If you don't have the handout, put it in the chat so I can send it to you right now. It is sent in the group, and I'll send it in the group again. But if you don't have it, say you don't have it, and I'll email you.
Thanks,
and I'm
Sherry.
sending it right now.
Perfect. So if 2/3 A minus B equals C, equals 1/4 C. So 2/3 A minus B equals 1/4 C, and B equals a -1 and C equals 20, find A. So this is going to be a problem where we're evaluating. We're going to plug in the different values that we have and try to find the other value. So take about a minute.
Okay, we have some C's, an A, and that's all I see for now. Could you hear me, Jonathan?
Yes. Sorry,
Okay.
I've been
No, you're fine.
muted myself.
All C's and A's right now.
Okay, good. I will tell you that it is one of those. And my test tip on this problem is check your answer. So if you got A or C, or even if you didn't, you may try substituting it back in and see if it actually gives you something that's true. And I'll show you that in a minute. Okay, so this one is complicated a little bit by the fact that there are fractions involved. So I'm going to work pretty slowly through the fractions for those of you all that just aren't real comfortable adding and subtracting, multiplying, dividing fractions. Here we're going to be multiplying fractions. Okay, so we have 2/3 A minus B equals 1/4 C. All right. So 2/3 A, so we're trying to find A, so it will stay. Now B is a -1, so we're going to have to be careful because we already have a minus here. So minus a -1 equals 1/4 C, which is 20. Okay. So looking at the left-hand side here, really all I can do to start with is I have this minus minus. So anytime you have minus a negative, You can think of it as like the opposite of a negative. So the opposite of a negative is a positive. So we have 2/3 a plus 1. So anytime you have minus a negative, you can make it a positive. And then you can think of this as 1/4 of 20, which is 5. Or you can think of it as 20 divided by 4, because 1/4 of 20 is the same thing as 20 divided by 4. And so either way, you'll get 5. All right, so now we're back to an equation here where we're trying to solve. So again, remember, we'll do addition and subtraction first. So we have this plus 1. So the inverse is going to be minus 1 on both sides. 1 minus 1 is 0. So we have 2/3 a equals 4. Now, it is possible to go ahead and, so for those of you all that are more comfortable with algebra, you can multiply both sides of this at this point by the reciprocal here. So this is 2/3, so you can multiply both sides by 3/2. That's fine. I'm going to show it in 2 steps because I think it's a little easier for people sometimes to see it in 2 steps. So because we have a division sign here, divided by 3, I'm going to multiply both sides by 3 first. So 3 divided by 3 is 1. So now I'm just left with 2a equals 12. So I'm going to move up here now. So 2a equals 12. Now that's 2 times a. So the inverse of multiplication is division. So I'm going to divide both sides by 2. And I have a equals 6. And so the tip I was telling you is that once you get a equals 6, you can actually go back and substitute it in here and see if this ends up giving you something that's equal. So let me show you what that looks like. So this would be only if you have time. If you're in a crunch for time, I wouldn't worry about it. So 2/3 times a, we got 6, minus a negative 1, which is plus 1, equals, and then 1/4 of 20 we said earlier was 5. Now, 2/3 of 6, you may just know, like thinking about it, 1/3 of 6 would be 2, and then another third, 2, 2, 2. So you can think of it as 4 that way, or you can actually do 2 times 6 is 12, divided by 3 is 4. So 2 times 6 is 12, divided by 3 is 4. Plus 1. Is 4 plus 1 5? Yes, it is. So we just checked our answer. So the answer is A equals 6, and that is choice C. All right, so again, if you have questions on that, I'll take questions on the next group here in just a couple of minutes. But I do recommend, if you have time and you're able to check your answers when you can. Okay, the next one we're going to look at together, because if you don't know the slope-intercept form equation for linear equations, which I'm assuming a lot of you all, it may have been a while since you've seen that, then you can't really get very far in this problem. So it says, which of the following is the graph of the linear equation y equals a negative 1/2 x plus 3? This is going to be one of those important formulas to know. So let me hop back out into Paint for a minute and actually show you this equation. So y equals mx plus b. So this is an important equation when you're dealing with lines, linear equations. All right. So m, anybody remember in the equation y equals mx plus b what m stands for? If you do, type it in the chat and let's see what we have.
Few people said slope.
Yes, that is exactly right. So that's going to be the slope of our line. Now slope, this is represented with an M. You may remember from long ago someone calling it rise over run. I like that. So if you're thinking of like a line drawn like this. So here's our line. Rise, we're talking about going up, but also down. So that means that you're dealing with the y-axis. So y values. Run is going left and right. So that's going to be your x values. So you're thinking about your y values in the numerator and your x values in the denominator. Okay, how about b? Anybody remember what b stands for in a slope-intercept form of a linear equation? Anybody?
So some people said intersection with y when x
Yes.
equals 0. Someone said y-intercept, offset, y-intercept.
Yeah, so it is called the y-intercept, and whoever described it did a good job. So the y-intercept is going to be when x equals 0. Where is this? So like on this one that I just kind of hand drew here, the y-intercept is right here. It's where the line hits the y-axis or where the x value is 0. Okay, so that's the pieces that we have. So in the problem that you're looking at now, it's y equals -1/2 x plus 3. So using this equation, we know that this -1/2 is the slope, and this 3 here is the y-intercept. So that's very helpful. That means that our graph is going to hit the y-axis right here, and the slope is -1/2. Now remember I said with slope, we're looking at rise over run. So if you think of -1/2, so a rise of -1 means you're going to go down 1, so down 1. And then a +2 means we're going to go right 2. So if we start at our y-intercept here, and we go down 1 and to the right 2, we're going to have something that looks like that. Then if we go down 1 more and right 2, something that looks like that. And so you can see we can kind of draw our line in. So the slope, now one thing to keep in mind is if you have a negative slope, if you notice our line is going downhill. If we read it left to right, the line is going downhill. The first line that I drew was going up from left to right, so this one would have a positive slope. So the fact that we know that the negative here tells us that the line is going downhill from left to right. The 1/2 is kind of telling us that we're going to go down 1 to the right 2, down 1 to the right 2, and so on. And then the 3 is telling us that it's going to hit the y-axis at 3. So we can look at all of that information and see that it's going to be choice A, because you can see it's hitting the y-axis at 3. And then for the slope, you can go down 1 and to the right 2, and you'll see that you stay right on that line every time you go down 1 and to the right 2. The rest of them, you see none of them hit the y at 3, so the only one that it could be is choice E, but again, it is not impossible to draw it. We were able to draw it, so it's choice A is an apple. All right. Y equals mx plus b. That's a good one to know. Next, translate the following phrase into an algebraic expression. 5 less than twice a number. 5 less than twice a number. I'll give you about a minute on this one.
We got some 3 B's so far. Yeah, everybody's saying B.
Good. And it is B. Be real careful on this one. The one that a lot of people will choose is it's the trap answer is choice A, because they just read it as is, right? 5 less than, so I think, okay, 5 goes first, less than means subtraction, twice a number means 2 times the number. And so they'll just choose choice A. But when you see that less than, you have to think of it a little differently. Like think about if I said, what is 3 less than 10? Well, 3 less than 10 is 7. Well, to do that, you don't do 3 minus 10. 3 minus 10 would give you a -7. And so if I say, what is 3 less than 10, you're actually in your head doing 10 minus 3 to get the 7. So it's backwards. So anytime you see that less than, just keep that in mind. So 5 less than twice the number means that you start with twice the number and then you subtract 5 from it. And so it is going to be choice B as in boy. Good. All right, we'll do one more and then I'll take any questions that have come up within the last few problems. So yeah, so one of my test tips here, be skeptical of answers that are too good to be true. The people that write these tests, they're paid to come up with answers that you will pick that are wrong. I mean, they're called distractor answers. And so some people, literally their job in life is to make you miss multiple choice questions. So just be on the lookout for answers that sometimes are too good to be true. They may be. Okay, next one. The relationship between x and y is given by the following equation. 3x plus y equals 7. If x increases by 2, then y, so what happens to y when x increases by 2? So I'll give you about a minute on this one to see what happens.
All right, we got it. 1e. Another e.
I'm back, Sherry.
Hey, Wanda.
Hey.
So far, just e.
Good. Give you all just another minute or so. Sorry, every time I pull up Paint, I see how horrible my handwriting looks on. Sorry. Remember, I'm using a mouse. I would like to say that my handwriting is a lot better, but it's not. But I do
think
actually
you're
have
doing
a
great.
reason.
You're doing great, Jonathan.
So 3x plus y equals 7. Okay, so the correct answer is E as in Edward. This decreases by 6. There's a couple of ways that you can look at that. We're going to take a break for any questions that you have in just a minute. So I'm curious, for those of you all that ended up getting choice E, the way that you decided to tackle it. I'm going to show you one way, and here's kind of one of my test tips. If a problem seems pretty abstract, sometimes you can actually plug in some numbers and make it concrete. And this is going to be one of those cases. So we want to know what happens when x increases by 2. So what you can do is you can start with some value of x and make it increase by 2 and see what happens. So in this example, I'm going to pick, for instance, 0 because 0 is really nice to work with. And so if I plug in a 0 or substitute in a 0 for x, 3 times 0 is 0. So I'm left with y equals 7. So again, if I substitute in a 0, for x, I get y equals 7. So now I want to know what happens when x increases by 2. So I want to see what happens now when it goes from 0 to 2. So if I substitute in a 2 for x, 3 times 2 is 6. I get 6 plus y equals 7. Now, we have addition between these, so the inverse here is going to be subtraction, because this is a positive 6. So subtract 6 on both sides, I end up with y equals 1. So what happened when x increased by 2? Y decreased by 6. So that's kind of a concrete way to look at that one, as x went up by 2. Now you don't have to pick 0 to start with. I could have started with x is 1 and saw what happens when x went up to 3. You could have done the same thing. So that's kind of a concrete way to do it. So that's kind of my test tip for this problem. If the problem's too abstract, try plugging in, substituting in some numbers to make it more concrete. All right, so that's 4 more problems. We'll take a little break here if anybody has questions, comments, and if anybody solved that one a different way and wants to kind of share how they did it, I'd love to hear what you did. Any questions, concerns, comments? All right, we're going to keep plugging along then. Here, let's see. Go back to my desktop. We'll hop on along. All right, so this is a fun one. Okay, there are 25 animals. They're all chickens and goats on a farm. If the farm animals have a total of 66 legs, how many goats are on the farm? So 25 animals, they're all goats and chickens. If these farm animals have a total of 66 legs, how many goats are on the farm? I'll give you a minute.
Okay, we got 1A so far.
Okay.
I'm waiting for some other people.
Okay, so some of y'all can keep working. Also in the chat, can anyone tell me what I have just drawn?
$25 animals.
Yep, there's my 25 animals, and they all have 2 legs, so they're all chickens. So I'm going to show you one way that you can tackle this one. If you're more of a concrete person and algebra is not your favorite, one way that you can tackle this one is to actually kind of draw out. You don't necessarily have to draw the entire thing, but this would be 25 farm animals, and they're all chickens. So if they're all chickens, how many legs are they going to have? And again, feel free to just shout out the answer or put it in the chat box if somebody can read it to me.
We've got 50.
Yes.
50,
We've
So-
got
yeah.
2. Yeah.
So if they're all chickens, then we would have 50 legs. How many legs do we need? We need 66 legs. So how many more legs do we still need? So we need
There you
16 more legs. And so every time that I take one of my chickens and I convert it to a goat, I pick up 2 more legs, right? So how many goats am I going to need in order to get 66 legs? So if I add 2 more legs to each of these animals, that's 10 more legs. So how many total goats are we going to have?
We got
8.
4 and 8.
Yeah, so it's going to be 8. Now, it is true for those of y'all saying 4, you're probably thinking 16 legs, 4 legs on a goat, so 4. But remember, these were chickens, and so we already had 2 legs, so we just added 2 more legs to each, and so that ended up giving us now 8 goats. And you can check it. So if we have 8 goats, they have 4 legs, then that means we have 15, 16, 17 chickens with 2 legs, and then you can kind of add those together to get your 66 legs. All right, so that's one way you can do it. Now, that's not the algebraic way, but no one says that just because a problem is in the algebra section, you have to do it the algebra way. So that's another tip I'll give you. Sometimes you can work some algebra problems without even doing any algebra. This is one example. The algebra way to tackle this is using something called system of equations. I'm not going to work the entire system of equations, but for those of you all that have taken algebra recently enough that you remember system of equations, I'll at least show you the setup. Actually, I'm going to change it and not use X. So I'm going to let C be the number of chickens. So the number of chickens can be C. We'll let G be the number of goats. And so you can use the information in this problem to set up two equations. So one is we know how many animals are on this farm. There's 25 animals. So the number of chickens plus the number of goats has to be 25. Now the only other information that we have is about the number of legs. So we know that chickens have 2 legs. So for every chicken, we need to multiply it by 2 to get how many legs we have of chickens. Goats, we know have 4 legs. So we're going to multiply 4 times G to figure out how many goat legs we have. And we know that we have a total of 66 legs. So number of chickens plus the number of goats equals 25. The number of chicken legs plus the number of goat legs equals 66. Now that's called a system of equations. If you have 2 equations, 2 unknowns, you can now solve that using either the substitution or elimination method. I highly recommend, if you don't know how to do that, you might want to look at like a Khan Academy video or something where they kind of walk you through. Again, it's called System of Equations. Systems of Equations. So Systems of Equations. Okay. So that's going to be the other way that you can solve that problem. All right, let's keep moving. So again, you don't have to necessarily follow the textbook approach on these problems. The textbook approach here would be using system of equations. You could just use pictures in this example. Okay, solve the following inequality. 2x plus 1 is greater than 4x minus 5. 2x plus 1 is greater than 4x minus 5. I'll give you a minute.
Okay, we have 1C.
Okay. Anything else?
Yes. Someone said, do you change the sign when you divide?
That is a good question. I'll answer that in just a second.
Okay. And then we have, so far we just have 2 C's.
Okay. I will tell you in this problem, we will end up changing the sign. It's not just because we divided though. So 2x plus 1 is greater than 4x minus 5. So the nice thing about inequalities is that you solve them very much like you do equalities. So the very first problems that we were looking at. So in this case, we want to solve for x. So in order to do that, we have to get the x's together. So we have x's here, x's on this side. And so what we can do is, you don't have to do it this way, but I'm going to subtract 4x on both sides because I typically like to have the x's on the left-hand side. So I'm going to subtract 4x on both sides. So 4x minus 4x is 0, so that's nice. 2x minus 4x is negative 2x. So now I have negative 2x plus 1 is greater than a negative 5. Negative 2x plus 1 greater than a negative 5. Okay, so now, again, we're going to follow our rules here where we're going to do inverse operations starting with addition and subtraction. So because of the plus 1, I'm going to subtract 1 on both sides. So I now have negative 2x is greater than a negative 6 because negative 5 minus 1 is negative 6. And now, since it's negative 2 times x, the inverse operation will be division. And the reason that I have to flip my sign is because I divided by a negative number. That's going to be the case where you're going to have to change your sign. If you multiply both sides of an inequality by a negative number, or you divide both sides of an inequality by a negative number, you're going to have to change the sign. So negative divided by negative is now positive, so it's going to be x. It was greater than, it will now become less than. A negative divided by a negative is a positive, so it will be x is less than 3, which is choice C as in Charlie. So x is less than 3. So remember, when you're dealing with inequality symbols, the less than, greater than, less than, or equal to, you can still work them like you do equalities, but if you divide both sides by a negative number or you multiply both sides by a negative number, you do have to remember to flip the sign. So x is less than 3. Okay. And again, if you have questions about that, hold it for just a couple more problems. We're almost done. This one I think we'll look at together because there's a lot going on in this problem. First, let's kind of read through it. The second angle of a triangle is twice as large as the first, and the third angle is 20 degrees less than the first. Given that the sum of the measures of the interior angles of a triangle is 180 degrees, find the measure of the third angle. Okay. So if you notice, both of the angles they give us here, they're referencing back to the first angle. And so that's kind of helpful to know. So the second angle is twice as large as the first. The third one is 20 degrees less than the first. So when I read that first sentence, that tells me that I want the first angle to be x, because we're going to keep referring back to that angle. So whenever I read that problem, that's what it makes me think. So let's hop over to Paint. So I recommend on these problems that, again, keeping up with your variables. So I'm going to let x be equal to the measure of the first angle. So I'm going to call that the measure of angle 1. Now it says the second angle is twice as large as the first. So the measure of angle 2 then is going to be equal to 2 times x. And then it says the third angle, so the measure of our third angle is 20 degrees less than the first. So if the first is x, 20 degrees less than that will be x minus 20. So that's kind of how I would get started there. Is, okay, the first angle, we don't know what that is. I'll call it x. I know that the second angle is twice as large as this one, so we'll call it 2x. And we know the third angle is 20 less than the first one, and so I'll call that x minus 20. And we know that the sum of the measures of all the angles of a triangle will be 180. So when I add them together, x plus 2x plus x minus 20, when I add those, I should get 180. So from here, it's now basic algebra, but that's the tricky part, is the setup. So again, I recommend deciding what you want x to be, and then kind of working from there. And then labeling these is very helpful. So if I know the first angle is x, the second one's twice as big, so 2x. The third one is 20 less than the first, so that's going to be x minus 20. That's the hard part of this problem. From here, now adding these and setting them equal to 180, this now is not too bad because we have x plus 2x plus x, that's a total of 4x when I combine like terms, minus 20 equals 180. And now we're back to our problem like number 1, because we have minus 20. The inverse operation is to add 20. So we get 4x equals 200. 4 times x, so we're going to divide both sides by 4. So we get x equals 200 divided by 4, which is 50. Now, be careful. If you've done all that work and you get x equals 50 and you pick choice B, then you fell into their trap. Because what is 50? 50 is x. What is x? X is the measure of angle 1. But it doesn't ask you for the measure of angle 1. It asks you to find the measure of angle 3. So watch for that. So if the angle of measure 1 is 50, 2 times 50 is 100. So the measure of angle 2 will be 100. Measure of angle 3 will be 20 less than 50. So 50 minus 20 is 30. So that is going to be choice A as an apple. So number 11 is A as an apple. So a lot going on there. I'll leave that up for just a second. And we'll look at one more algebra problem. I'll take any questions that you have, and then we'll move over to geometry, which I saved geometry for last because just like this problem, this is a geometry problem, but it also involves algebra. So this one is 30, which is choice A, apple. Okay, one more. The cost of movie tickets for adults at Showbiz Cinema is shown in the graph below. Based on this information, what is the cost of 2 movie tickets? So you have to be careful. Sometimes these problems look like they're pretty straightforward, but there's a trick to them. And so this would be one of those. So adult movie prices at Showbiz Cinema is shown. And of course, when you look at the cost of 2 tickets, you notice that it's somewhere between 10 and 20. But look at our answer choices. 15, 16, 17, 18, those are all kind of in that realm of possibility, right? And so it's a little hard to tell exactly where that is. So who has an idea? So since it's kind of hard to look at 2 tickets and figure out exactly where that's hitting, anybody have a suggestion on maybe a different way that we could approach figuring out how much 2 tickets are going to cost?
You have some answers? Sorry, go ahead.
I'm sorry, I was going to say we can look at 5 because that fits squarely on the graph against.
Yes. That's what I would recommend. So it's pretty obvious that, yeah, 5 tickets falls directly on $40. And so if we know that 5 tickets cost $40, we can do $40 divided by 5. So 1 movie ticket then is going to cost $8. So therefore 2 movie tickets are going to cost $16, which is choice C as in Charlie. So again, if it's not obvious looking at 2, then let's move out, look at one that we can figure out and use that to help us. And so the answer is going to be C on this one, $16. Good. All right, so we'll take just a second. I'll stop sharing. Any questions on any of the algebra ones, or questions, comments, concerns?
Jonathan,
Yes.
would you mind going through the answers for the algebra questions again for me real quick?
Absolutely.
Just the letter is fine.
Yes. So 1 is B as in boy, 2 is D as in dog, 3 is E as in Edward, 4 D as in dog, 5 C as in Charlie, 6 A as in apple, 7 B as in boy,
Okay.
8 E as in Edward, 9 A as in apple, 10 C as in Charlie, 11 A as in apple, 12 C as in Charlie.
Got him. Thank you so much.
You're very welcome.
I have a question about.
I have a question.
Sorry, go ahead.
I got a question, Mr.
Yeah, tell me.
Okay. So is the only time you change the sign when dealing with inequalities is when you divide by negatives? Is that the only
Or
time?
usually that's when it's going to be. It's also if you multiply both sides by a negative.
Yeah, okay.
And let me share my screen for just a second, and let me hop into Paint. There is one other thing, so I'll just make sure that it's clear. So yeah, so when you have an inequality, so if you had something like, I'll give you an example. So if you had like -1/5 x is greater than -7. So in this case, I would need to multiply both sides by a -5. So a -5 divided by this -1/5 would cancel out then. So in that case, I would also flip the sign. Usually it's going to be the case that you had a minute ago, something like, -5x is greater than 10, and you're going to divide both sides by a negative there, and then you'll flip the sign. So either of those cases, multiplying both sides by a negative number or dividing both sides by a negative number, you'll need to flip the sign. Also, if you end up with like the x on the wrong side, say you have like 3 is greater than x, but you need to know, like maybe the answer choice is the x's first. So in that case, if you need to flip these, then you would also have to flip the sign.
Okay. I needed this refresher. Thank you.
Yeah. Good. Okay. Other questions, comments?
This is a general question, Jonathan.
Yes.
For the questions that we've seen so far in algebra and probably in geometry too, how much time are we given per question?
You're given about 1.5 minutes per question. On the newer version of the test, you have just a little bit longer, but you have to average at about 1.5 minutes a question. Some will take longer than 1.5 minutes for sure, but then you can make up some time on some of them that are more conceptual where you don't have to do a lot of work. You just have to kind of look at the answer choices and pick one. But on average, so what I would recommend is while you're taking the test to not time yourself per question. You'll really stress yourself out. But maybe, if you have 1.5 minutes per question, maybe you wait for like 10 minutes or 10 questions and see where you are. So, you should finish 10 questions in about 15 minutes. So maybe after 10 questions, make sure that not much more than 15 minutes has passed, and then keep going.
Gotcha. Thank you.
Yeah. Other algebra related questions? Okay, so we're going to hop over to geometry now, and so I'll jump in here. Let me share my screen again. Okay, so first geometry topic. So what are some of the things that you'll be asked to do? Obviously geometry, there's a lot in geometry, but you're only required to do a certain amount of things. Being able to calculate the perimeter, area, and volume of various shapes is important. Perimeter is where we're measuring like the length of the sides of something. That would be perimeter. Area, you could think about like how much carpet does it take to fill an area, or how much paint it would take to cover a wall. That's kind of area. Volume, how much water does it take to fill up a swimming pool? And now we're looking at three-dimensional objects. So perimeter, area, and volume of various shapes. I'll tell you some of the formulas that they expect you to know. Transformations, which sounds scary, but I'll show you an example of kind of what that looks like. Classifying triangles. So we have there's scalene, isosceles, equilateral triangles. There's different types of quadrilaterals. We'll look at a problem that involves what's called the triangle inequality theorem. So I'll show you how to apply that theorem. Pythagorean theorem is a big one. That's the one, the c squared equals a squared plus b squared, and we'll look at that. Parallel lines cut by a transversal, and circles. Circumference, that's kind of like finding the perimeter of a circle. Arc length, sector area, those kind of things. And so we'll look again at some examples of those type of problems. Okay. Let's just jump right in. So I've got 8 of these. Again, on some of these, I'll give you some time. Some of these will work together. And then I'll stop after the first 4 and the next 4. And then I'll kind of have some closing stuff before we end today. All right, so the first one is the dimensions of 5 rectangles are given below. Which rectangle has an area of 12 square inches and a perimeter of 16 inches? So take a minute.
Jonathan, we've got a B and a C.
Okay. So let's start by looking at area. So area of a rectangle is one that you will be expected to know on the test. So an area of a rectangle is length times width. So right away, if we multiply these side lengths, you can automatically eliminate choices D and E because when you multiply them together, you do not get 12 inches squared, right? So D and E are automatically out. Now, if we multiply A, B, and C, if we multiply these together, we do get 12. So it has to be either A, B, or C. So now we look at perimeter. And again, remember that perimeter is we're measuring the length of all of the sides, okay? So for instance, we look at the 1 and the 12. So if this was 1, 12, 1, 12, basically we have to take the 1 and we have to multiply it by 2 because we need 2 of those, and we need 2 of these lengths. So if we did that, we'd have, 2 times 1 is 2, 12 times 2 is 24. So 24, 25, 26. That would be 26 inches for the perimeter. So that's not going to work. So A is out. If we look at choice B, what if we make each of these 2 and each of these 6? So 6 plus 6 gives you 12. Plus 2 plus 2, that's going to be the 16 inches. So it looks like it's going to be choice B. If you chose choice C, you're close. So if you look at C, if we do 3 and 3, we get 6. 4 and 4, we get 8. So 8 and 6 is going to give you 14. So it's close, but it's not quite the 16 inches. So it's going to be B as in boy. So remember, for area of a rectangle, it's length times width. Perimeter is going to be 2 times the length plus 2 times the width. And I'll give you that formula at the end. All right, on we go. So in this problem, we're given that lines Q and M, these two lines, are parallel to each other because they never touch. Find the measure of angle 5, which is down here. So you're given that this angle at the top is 110. This angle is 115. Use that information now to find the measure of angle 5. I'll give you about a minute while I try to set this up in Paint. So I've tried to recreate the drawing there. So you're given 2 angles. You're given that this angle is 115. This angle is 110.
We've got a B.
Okay.
Another B.
So type in the, so are you all able to see my cursor moving around? Sherry, okay.
Yeah, I can see it.
Good, okay. I thought I changed my color here, okay. So
People in
given,
the group said they can see it as well.
good, okay. So given that this angle is 110 degrees, this where I've got the blue circle, what will this angle be right here? Feel free to type that in the chat. So
Bunch of 70s.
Yes. So it'll be 70, because if you think about a straight line, again, this is kind of a straight line here, right? The measure of this straight line is going to be 180 degrees. So that's important to know that a straight angle is 180 degrees. So you can use that same thing here. We have a straight line here. Use your imagination. And so if this is 115, then this one has to be, for the same reason, 65, right? So we got 65 and 70. Now what about here? What will this angle be where the pink circle is?
Yeah, 45s.
Okay, so it's going to be 45. If you're wondering why is it 45, it's 45 because this is a triangle. And remember from our earlier problem, the sum of the angles of a triangle will always be 180. So 70 plus 65 plus 45 will give us 180. Now there's a couple other rules that you have to know, and that is the fact that here, well, there's a couple things. Here, these are parallel lines. And you may have heard me earlier talk about parallel lines cut by a transversal. And so this angle and the red angle that we're trying to find, those are called corresponding angles. And the important thing about corresponding angles is that they are congruent. So that if this angle is 45, then this one will also be 45. Another way that you could find it is, you know, this one's 45. This angle across from it is called a vertical angle. It's also going to be 45. So these two angles are going to be 45. And then these angles, one's, if you notice, if you're looking at the orange here, these parallel lines cut by a transversal, if you notice these two angles are alternating and they're on the inside. We call them alternate interior angles. They're also going to be congruent or the same. And so either way you do it, you'll end up with 45 degrees for that angle. Now, parallel lines cut by a transversal, if that's something that you're like, I have no idea what you're talking about, if you'll look on the next slide, I give you an example of parallel lines cut by a transversal. So let's say that angle 1 is like just make it easy, we'll make angle 1 100 degrees. Then again, as I was telling you, this one across from it's called a vertical angle. So angle 3 would also be 100 degrees. 3 and 8, those are called alternate interior angles because they alternate and they're on the inside. Those would both be 100 degrees. Therefore, 1 and 8 would be the same. That's what I was talking to you about earlier. Corresponding angles are the same. So 1 and 8 would both be 100 degrees. 8 and 6 are what you call vertical angles. Oops, sorry. So they would both be 100 degrees. So basically 1, 3, 8, and 6. 1, 3, 8, and 6. Those would all be 100 degrees. And you could do the exact same reasoning to find out that 2, 4, 5, and 7, the rest of them, 2, 4, 5, and 7, would all be 80 degrees. So you have alternate interior angles are the same, vertical angles are the same, corresponding angles, so like 1 and 8, 3 and 6 are also corresponding. And then the last one I haven't mentioned is alternate exterior, the ones on the outside that are alternate. So 1 and 6 are both 100, 2 and 7 would both be 80. So those are some of the relationships. You could look this up. So again, you could do a quick Google search of parallel lines cut by a transversal, and they can review all of the different types of angles with you. The most important thing to probably know, though, is which ones are the same. So 1, 3, 8, and 6 are congruent, which means the same. 2, 4, 5, and 7, again, are congruent, and the word congruent means the same. So congruent angles mean that the measures of the angles would be the same. You can also have congruent sides, which means the side lengths are the same. Okay, next one. Which geometric transformation is illustrated in the figure below? So we're starting with this figure ABCD, and the transformation is it moves here. So ABCD. And you see the little marks with it, that just means that's the transformed version of this. So is that a translation, dilation, rotation, reflection, or none of these? So I'll give you just a second to tell me what you think. And feel free to type it in the chat.
You got C, A.
C's and A's?
Yep.
Okay. So let's go through them one by one. So translate just means to move. And so if we take this rectangle and we just shifted it somewhere, then the answer would be choice A. That's not exactly what's happening here. So why is this one not a translation? The reason is because it's also turned. And so for a translation, you can only move up, down, left, or right. That's all you can do with the translation. Up, down, left, or right. You can't actually turn the figure, okay? With dilation, it's either getting like bigger or smaller. You're either expanding it or shrinking it. And so that's not what's happening here. So the answer here is it is a rotation. And if you think about it, if you think about like the rotation point being like this point 0, 0 right here where the red and the blue line meet, and you can think about it being a turn, right? So if you started with the first figure and you turned it, you would get the second figure. So that's why it's a rotation. It involves a turn. It's not a, so sometimes in school we'll use the word for translation like a slide, like you're sliding it up, down, left, or right. A flip would be the reflection one, and then rotation would be a turn. So this is going to be a turn, so it's choice C. Reflection would be, it's a flip, right? Like you take the one shape and you flip it, maybe over the red line or over the blue line, and you would get a reflection then, kind of like a mirror image. And so this one is going to be choice C. Now here's your bonus points. It is a rotation, so how much is it rotated and what direction is it rotated? So is it I'll give you a choice. It could either be rotated 90 degrees, 100 degrees, or sorry, 90 degrees, 180 degrees, or is it the rotation a clockwise or counterclockwise? So take just a second. And again, remember, we're starting with this one, the ABCD. So is it 90-degree rotation or a 180-degree rotation? Is it clockwise or counterclockwise? Because they may ask you those kind of things as well. Feel free to type it into the chat, your guess. Any guesses?
We have clockwise. Everyone says 90 to the right. Everyone's saying 90. And then some people said 90 counterclockwise.
Yeah, so it is going to be a 90-degree turn. And so if you take it, sometimes I tell people if they have trouble visualizing it, like drawing it on a little sheet of paper and then just turning your paper. So 90 degrees would be a quarter turn. So it would be taking your paper and then just turning it from one side to the next. And in this case, since we're starting with this one, it will be counterclockwise because we're moving again from here, again counterclockwise to the center.
There's one question.
Okay.
Letitia?
Okay, so how do we know we were starting with the one on the right?
Because I told you. The main reason that you know, they wouldn't ask you a problem quite like this. They would do a little bit better wording than the problem I came up with. If you see one shape that has just letters and the other one has like these little tick marks here, that's letting you know that the second one is the image, but you wouldn't be expected necessarily to know that. They would do a little bit better job saying you're starting with figure ABCD, and once you change the figure or transform the figure, it will be A prime, B prime, C prime with the little tick marks. You know, they would word it a little bit better. That's a good question.
So if we merely rotated it, then wouldn't B and C land on the y-axis?
So if you rotated it, now it depends on where you rotate it from. So on this one, you're rotating it from the point 0, 0. So it'd almost be like, so what you can do is if you draw this like on a piece of paper and then just turn the paper a quarter turn, you'll see that it'll give you exactly the other image. But that's if you rotate it on about the point 0, 0.
Oh, so we're rotating both the x and y axis, is not just a figure.
Yes.
Oh, okay.
Yeah. You can rotate it lots of different ways. But yeah, if the way that I have it drawn here is that it was rotated where you're rotating, the whole thing about the point 0, 0.
We have wouldn't it be A and C?
So it can't be A just because, remember, with A, with the translation, you can only move up, down, left, or right. You can't turn it. And so the fact that the rectangle is turned on its side, it can't be choice A. It would have to be exactly the same shape, just moved. You can't actually turn it. So that's the difference with the translation. You can only go up, down, left, or right. So it's still going to be a rectangle that is 3 wide and 2 going up and down. Like it has to stay like that, if that makes sense, hopefully.
So we have at the same time moving and rotating.
So yeah, so on this one, it's actually, you're actually turning the whole thing. And so if it involves turning the shape, then it's going to be a rotation.
Oh.
Does that help?
Oh, I'm sorry. I'm not muted.
I was just going to say, can you talk without your hands?
No. It kills me to do it this way, and especially because I can't see people too, unless I get out of share mode. Okay, so for the sake of time here, I'm going to keep moving, then we'll take a quick break after this one to see if there's any other questions. All right, two sides of the triangle measure 5 centimeters and 7 centimeters. Which of the following side lengths are possible for the third side? I will go ahead and tell you for the sake of time, we're going to talk through this one together. This is a problem that involves the triangle inequality theorem. The triangle inequality theorem is not real important that you know exactly what it says, but that's what we're going to use on this problem. And so we can't just have any side length here. If you think about it, if this one is 5 and this one is 7, if this side is too long, then we're not going to be able to connect it. And if it's the same kind of issue happens if it's too short, and we're not going to be able to get all 3 pieces or sides of our triangle to connect. And so there's a real easy way to determine what are possibilities for this third one. And I'll show you what it is right now. So go back over to Paint. So we know that one side length is 7 and the other is 5. If you add these two numbers, we get 12. If you subtract the two numbers, you get 2. So those are the first things that we need. We need to know 12 and 2. Now, triangle inequality theorem says if we add these two and get 12, then that means that the third side has to be less than 12. And when we subtract them, we get 2. It means that the third side will have to be greater than 2. So the third side is going to have to be bigger than this number and smaller than this number. That's what it means. That third side has to be somewhere between those side lengths. So 2 and 12 is kind of our boundaries. So if we look at this problem, 1 centimeter, it's going to be too small. 13 is going to be too big, but the 3 in the middle are going to be just right. This is the Goldilocks problem. So I is not a good one. V is not a good one because I is too small. V is too big. The 3 in the middle are just right. So the answer is going to be choices 2, 3, and 4 here. So 2, 3, and 4, which is going to be choice B as in boy. Now on this problem, it wouldn't be written this way. What would end up happening would be that they would just tell you to check the sides of all of the ones that would be the correct answer. So you would pick these 3 individually. And I put on here, it never hurts to draw a picture, because if you're having trouble here, maybe drawing a picture will help you kind of see that if your side is too small or too big, that the three sides won't connect to make a triangle. Okay, so I'll stop there for just a minute. We've gone through 4 geometry questions. I know some of you all have already asked your questions along the way, but any other questions that you all want to ask right now about the first 4 geometry questions?
So we have someone who's saying, can you go back to the paint screen for a second?
Yes, absolutely. Maybe. Let's see.
Now, can you repeat why you subtracted and added sides on 4?
So yeah, so again, it's the idea of the triangle inequality theorem, and so I won't bore you with, but basically it just says that if you know 2 sides of a triangle, that the third side has to be smaller than the sum of those 2, and the third side has to be bigger than when you subtract the 2. And so that's coming from what's called the triangle inequality theorem. And so that's not something that's just intuitive that you should necessarily know, although drawing a picture may help you see why that this is the case. But again, it's called, if you want to look it up, you're more than welcome to, again, Google it. And it's called the triangle inequality theorem. But it just tells you that if you know 2 sides of a triangle, how the length of 2 sides, that the third side has to be smaller than the sum, and it has to be greater than when you subtract the difference between those 2 sides.
Did that answer your question, Maria? She said yes. Okay.
Okay. Yeah, and you can look that up, but that's basically what this triangle inequality theorem says. And it's based on the idea of, again, if you were to draw, so let me just show you an example. Like if I were to draw like, these 2 lines and say, how long can the third side be? I mean, if the third side is like this big, clearly those 3 sides are not going to be able to connect to each other to make a triangle. Like you can't get those 3, this point, there's no way to get that little point. Here, let me change colors. The end point there and the end point here, they won't reach each other. And so it can't be too big, and the same reason it can't be too small, or you won't be able to get them to connect. But that's kind of the easy way to figure out what the range will be. You add the 2 sides, subtract the 2 sides, and then the third side will have to be somewhere between these 2. Good question. Other questions on the first 4? All right, 4 more to go. We'll hop back in. So again, never hurts to draw a picture, especially on the geometry questions. If a picture will help, please do it. While we're talking about triangles, it doesn't hurt to also quickly review the types of triangles. So here you can classify triangles based on their angles. So an acute triangle means that all of the angles of the triangle are less than 90 degrees. Obtuse means that you have one angle that is greater than 90 degrees. So in this case, this angle is greater than 90 degrees, so this would be an obtuse triangle. A right triangle means that the triangle has a right angle in it, and a right angle is 90 degrees. So you can classify triangles based on their angles, also on their side lengths. So an equilateral triangle, all 3 sides of the triangle are the same length. With an isosceles triangle, 2 of the side lengths are the same. And then scalene triangle, all 3 sides of the triangle are different lengths. So all lengths the same with equilateral, 2 the same with isosceles, all 3 different with scalene. So that's kind of classifying triangles. So you get that for free. Actually, you get it all for free. Okay, number 5. The volume of a package, and so it's a rectangular prism, which is a nice way of just saying kind of like a, think of a box. So the volume is 4,692 cubic inches. If the length of the package is 23 inches and the width is 17 inches, what is the height of the package? Now, if you need a quick reminder of what the volume of a rectangular prism is, it's pretty straightforward. You just expand the area of a rectangle. So the area of a rectangle is length times width. The volume of a rectangular prism is just length times width times height. So volume V equals length times width times height. So take a minute and see what you come up with.
We don't have any responses just yet, Jonathan.
Okay.
We've got A
Okay,
and
we
we've got
have
12. I'm sorry, Sherry.
no. You go right on ahead.
I jump in and out of attention. Jonathan loses me a lot. Okay, another A. To me, he might as well be speaking a foreign language.
So the volume is equal to length times width times height. Again, this is when we're dealing with rectangular prisms, which is a fancy way of saying a box. Hey, that's a pretty good box for Microsoft Paint here. Okay, so length times width times height. So we know the volume is 4,692 cubic inches. Length is 23. Width is 17, so I substituted in those values. 23 times 17 is 391 times H equals 4692. And since it's 391 times H, again, we're going to use algebra here. We're going to divide by 391. Remember, you will have a calculator. So you can use your calculator here to come up with the height is 12 inches. Good. So for those of y'all that got choice A as an apple, 12 inches, that is correct. Again, I'm looking at time. We've got about 20 minutes left, so I'm going to keep moving along, but hang on to your questions. There'll be some time for questions here in just a few minutes. I think the next one, it's pretty tricky. Historically, a lot of people have issues with the next one, so we'll look at it together. Again, just reminding you, algebra is a powerful tool, so definitely recommend on the geometry section, you'll definitely need to use algebra for some of the problems. Question 6, the second hand of a clock is 5 inches long. Approximately how far does the tip of the hand travel in 45 seconds? So what we're thinking about here is, so this second hand is 5 inches long. So if you notice, we've got a circle. Hopefully you remember that this length here, this 5 inches, it's going from the center to the edge of the circle. This is called the radius. So half of the circle, so if you're going all the way across, it's called the diameter. Halfway, it's called the radius. It's 5 inches. So we can find the circumference. Remember, the circumference is the perimeter. It's going around the outside of our circle here. So what I'm going to do in this problem is I want to know how far this is going to travel going 3/4 of the way around. But let's start by just finding out what is the circumference of this circle. So that's an important formula to know. So I'm going to hop out for a minute and jump back over to Paint. So in this problem, we have a clock. And we know that the second hand is, again, 5 inches long. So the circumference formula is 2 pi r. So the circumference of a circle is 2 pi r. And pi is about 3.14. So circumference is going to be 2 times pi. And in this example, the radius that they give you is 5. So that's going to be 10 pi. So 10 times 3.14 will be 31.4. So 31.4 inches is the circumference. So if you stop there and pick choice E as in Edward, because that's there, you will fall into the trap and get the answer incorrect, because again, it didn't ask us what's the distance all the way around the clock, which is what we have right now. It wants to know how far does the clock, or the hand, second hand, how far does it travel in 45 seconds? Well, how far around the clock do we go in 45 seconds? So type that in the chat. So if we start here and the second hand is moving for 45 seconds, how far are we going across?
We got 3/4.
Yes, 3/4 of the way around, 3/4. So now all we need to do is take the number that we got, 31.4. Oops. Just kidding. So you take 31.4 and we just multiply it by 3/4 or 0.75. So you can use your calculator, multiply 31.4 by either 3/4 or 0.75. And I ended up with 23.6.
Yeah, we've got a 23.55 in the chat.
Yeah.
D.
So so it rounds to 23.6 inches, which is choice D as in dog. So that's one that involves using the circumference formula, because we're trying to figure out how far that second hand traveled. So that's going to be the distance around the circle. That's the circumference. So that formula is 2 pi r. You will be expected to know that on the Praxis, that the circumference of a circle, 2 pi r. And we'll get to it in just a little bit. Or actually, I don't think we have. Yeah, we'll get to it in a minute. But the area of a circle is pi r squared. So circumference, 2 pi r. Area of a circle, pi r squared. Okay. Now on this problem, my tip is sometimes you can use estimation to estimate choices. So again, if you know, looking at this picture, that second hand is 5 inches long, you can kind of estimate how far it would be then to go from the 12 all the way around to the 9. You can kind of use that fact that you know that that's 5 inches to kind of help you figure out what the other one would be. Like for instance, you can eliminate A and B pretty quickly because it's going to be a lot further than than 3.9 inches and 7.5 inches to get from the 12 all the way around to the 9. So estimation sometimes will help on some of these problems. Okay, next one, and again, for the sake of time, we'll just kind of walk through these last few together. A 26-foot ladder is leaned against the wall in such a way that the base of the ladder is 10 feet away from the wall. At what height does the top of the ladder touch? Oh, and I misspelled ladder the last time, so I spelled it right once and not right the other time. Sorry about that. Does the ladder touch the wall? If necessary, round to the nearest foot. Okay, so when you see this problem, and you see that right triangle, the first thing that should pop into your mind is what's called the Pythagorean Theorem. And so that's what we're going to use on this problem. And so that you can kind of see the right triangle drawn in here. So I'm going to hop over to Paint. And so what we have is something that looks like this. So this is my ladder here. Here, I'll mark it in red. So we've got our ladder, and in the problem, they tell you that the ladder is 26 feet long. We know that the base of the ladder is 10 feet from the wall. So this is the ground down here. So we're 10 feet away, and we want to know, so this is the ground, and we want to know it's hitting the wall up here. So we're trying to figure out what is this height right here, the blue. And again, we know that this is a right triangle. And so we can use what's called the Pythagorean Theorem. If you need a reminder, it's c squared equals a squared plus b squared. You can only use this formula when you're dealing with right triangles and you have 2 side lengths and you're trying to find the third. Another important thing is that C has to be what's called the hypotenuse. I'm going to spell this for you. Hypotenuse. The The hypotenuse is a fancy word for the side that is across from the right angle. So here's our right angle. So the side that is across from it, that's the hypotenuse. That has to be C. A and B are the legs. That's going to be the two sides that actually make up the right angle. Those, it doesn't matter which one it is because there's addition between them, so it doesn't matter the order. But C has to be hypotenuse, which is the one across from the right angle. So in this case, C is going to be 26 squared equals, now again, doesn't matter which is which here, so I'll make AX squared plus, and I'll make B 10 squared. So the two legs added together, squared first, squared and then added together, is equal to the hypotenuse squared. That's the Pythagorean theorem. C squared equals A squared plus B squared. Now 26 squared is just 26 times 26. That's going to be 676. 676 equals x squared plus 10 squared is just 10 times 10, which is 100. So we have 676 is equal to x squared plus 100. Now to solve this for x, we're going to need to subtract 100 on both sides. So I'll get 576 equals to x squared. Okay. Anybody know how I get rid of the square now? So I've got x squared is equal to 576. How can I get rid of that square? What is the inverse operation of squaring something?
We've got to take the square root.
Yes, so just like whenever we have addition, we subtract, and when we have multiplication, we divide. When you have a square, you're going to take the square root. That's going to be the inverse. So I take the square root of x squared, that's just going to leave x. And then the square root of 576, you'll again be able to use the calculator there. You'll get 24 because 24 times 24 is 576. So x is 24, and that's going to be choice C as in Charlie. That's the Pythagorean theorem. Okay, so last problem. Then I'll take any questions before I go through a few final things with you. Let me hop back out here. Last one, a circle with a radius of 5 centimeters is inscribed in a square. What is the area of the shaded region? Now, if you look at this problem, they love to give you problems like this where to find the area of the shaded region would be pretty hard to actually compute that. But what we can do is we can look at the fact that we have a circle and a square. It's pretty easy to find the area of those and use that to help us. And so what we could do is, you could probably see it if you look at it, if we find the area of the whole square and then subtract the area of the circle, that will give us the shaded part, which is what's left. So the answer to this question is going to be area of the square minus area of the circle. Now we just have to find those two things. And so I'll hop back over to Paint. Maybe I'll work over here on the side in case anybody has a question about this one. I'll leave it on there. So again, you have this square and you have the circle that's inscribed in it. And they tell you that the radius of the circle is 5 centimeters. So what is going to be the length of one of the sides, or each of the sides of the square then? My drawing is getting worse and worse. So just type that in the chat. What's going to be the
10 centimeters.
10. So it's going to be 10 centimeters. And so the area of our square is just going to be side squared, or length times width. So it's going to be 10 squared, or 100. And since we're dealing with centimeters, that's going to be centimeters squared. All right, the area of our circle, again, remember I told you that the area of a circle is pi r squared. In this case, the radius is 5. 5 times 5, or 5 squared, is 25. So the area of our circle is going to be 25 pi centimeters squared. So if we want to find the area of the shaded region, again, all we need to do is take the area of the entire square and then subtract out the area of the circle. So it's going to be 100 minus the 25 pi. And that's going to be choice D as in dog. And so let me quickly go back through the answers to these, and then I'll take a few questions. So for the geometry questions, the answer to question 1 was B as in boy. 2 is B as in boy. 3, C as in Charlie. 4, B as in boy. 5, A as in apple. 6, D as in dog. 7, C as in Charlie. 8, D as in dog. Okay. So let me stop sharing for a minute. Any questions about those 4 before I go through? So the last thing I'm going to do is go through the formulas and then just give you a few closing thoughts and a few more things that I think you might be interested in. Any questions?
Jonathan, I have a quick question. I don't mean to horn in when other people do. On the ladder one, the hypotenuse,
yes.
If you couldn't remember the formula and you were lost, you could make an educated guess on that, correct? And the reason I say that, because you know it's going to be shorter than...
No, that's
a 26-foot ladder, and you know it's going to be shorter, but not by a whole lot.
Exactly. So this would be another one where that idea of if you're really stuck, sometimes, estimating is a good way to do it, because the people that make these questions, they'll tell you sometimes on the problem that it's not necessarily drawn to scale, but it usually is, because the people making these questions are math people, and it drives them crazy to draw a picture that's not to scale. And so you can use that to your advantage. So if you have a picture given, then there's a decent chance, if you don't have anywhere else, if you're stuck, is to either look at the picture and use it, or again, just using your thought like you're saying, Wanda, of the fact that it is a 26-foot ladder. So if it's a 26-foot ladder, and it's leaned against the wall, it's not going to be taller than 26, right? And so you can go ahead and eliminate. D and E aren't even realistic, because if you're leaning a 26-foot ladder against the house, it can't be 28 feet high, because the ladder's not even that tall. And so and then you could kind of use your guessing to get you there. So yes, that's a good point. Okay. All right, so let me give you a few important formulas to know. And so again, we've talked about all of these throughout the time here, but the first one is, and maybe I'll go over to paint so that you all can see it instead of just hearing me say it. So the first one is a percent increase, decrease. We used that last week. That was the idea of it's the new minus the old divided by the old times 100. So if you're trying to calculate the percent increase or decrease of two different numbers, you start with the newest number, you subtract the original number, and you divide it by the original number, multiply that by 100. That's a percent increase, decrease formula. The next one says slope-intercept form of a linear equation. So slope-intercept form is what we talked about earlier today. That's y equals mx plus b, where m is the slope and b is the y-intercept. That's why it's called the slope-intercept form, because it gives you the slope and it gives you the y-intercept. So that's one that they'll expect you to know. The next one I've listed is the Pythagorean Theorem. That's the c squared equals a squared plus b squared. Again, c squared has to be the side that is across from the right angle. That's called the hypotenuse.
Hey, Jonathan?
Yes.
Are you drawing?
Yes, can you all not see me drawing?
No, all we can see is where it says some formulas to know, and then it's like I can see your cursor moving on top of it, but I don't see anything.
Good, thank you for telling me. I must be sharing.
Someone else, mentioned it, and I looked at it like, wait.
How about now?
Yes, there we go.
Okay, yeah, sorry, I must have been in a different type of share mode where, sorry. So percent increase, decrease, new minus the old over the old times 100. That was from last week. Y equals mx plus b, where m is the slope, b is the y-intercept. That's going to be the second one. Pythagorean theorem, c squared equals a squared plus b squared. Again, c has to be the side that is across from the right angle. A and b are the legs. Those are the two sides that are made up by the right angle. Area of a triangle is 1/2 the base times the height. So area equals 1/2 base times height. I believe we had a problem related to that last week. Area of a rectangle, just length times width. The circumference and area of a circle. So the circumference of a circle is 2 pi r. Area is pi r squared. Volume of a rectangular prism. So we tackled that today. So remember, if you're looking for the volume of a rectangular prism, that's my attempt to draw a little box there. It's length times width times height. One that we didn't do, but it's not that much harder to tack it on. They could ask you to give you the volume of a cylinder. So think about the volume of this box. It's just length times width, which was the rectangle, times the height. If you have a cylinder, what are the bases of the cylinder? The bases are going to be a circle. And so what is our area of a circle? It's pi r squared. And you could just multiply that by height, and that takes it from area of a circle to the volume of a cylinder. And then the last one, we didn't really do a problem related to this, but the fact that distance is equal to rate times time, that is a formula sometimes they expect you to know. Now, I don't promise that this is an exhaustive list, but from me working through several tests, these are the formulas that stuck out in my mind as ones that they did expect me to know, and they didn't give me. And so, so these are definitely, again, not necessarily an exhaustive list, but at a minimum, I would know these formulas.
Okay, we've got a question, Jonathan.
Okay.
Is the circumference of a circle formula the derivative of the area of a circle formula?
It does end up being that way. You know, to be honest with you, it's been a little while since I've thought about calculus and geometry together. So I don't know if that is, I would have to look at, I can't tell you exactly why, but yes, it does end up working out that the circumference of a circle is the derivative of the area. I should probably know if that's a coincidence or not, but I don't right off the top of my head.
Is that volume equal pi radius squared W?
Sorry, that's an H. Height.
Oh, well, okay, that's what I thought, and then I wasn't sure. Okay. All right.
Sorry, that's supposed to be an H. Yeah, so volume of our rectangular prism or a box is length times width times height. And for a cylinder, it's pi r squared height. So it's basically the base of the object times the height, base of the object times the height. Other questions about the formulas? Okay, so I'm not going to go through them all again for you, but what I've included on the next few slides
Can you all hear Jonathan? Yeah, Jonathan, you're frozen or something.
Yeah, something.
He just, hey,
I thought it was me.
no,
Then I saw everybody else moving. Can you write on the test or only on the extra paper? And I do not know. Jonathan is still frozen.
I just know that if it's electronic, they give you scrap paper, I believe. Because someone asked the same questions, that they'll give you scrap paper, but the test is digital, so you only be able to write on the extra paper that they provide you with.
And that's what we're being told in the chat.
Also, I'm going to put the materials into the group chat. When I submit this PowerPoint into the group chat, will you all let me know if you're able to download it? That would be helpful. And the reason, again, why some people are getting the materials in different spurts is because there was no email on the RSVP. That was a very major mistake I made. But we have a list of all the students anyway. So it's just been going out to all of the Louisville Teacher Residency students, undergraduates. I have access to their emails, and then MAT students. So right now I am putting the PowerPoint of part 2 So let me know if you are able to download it or if we need to send out an email blast again.
And
So
I'm going to tell you all, because I know Jonathan and he works over in Reach, and I know he's maybe not there except through the end of July, which he can clarify. But if you know that you don't understand something on, I don't know, because I didn't understand any of it, but something on, let's say in the geometry portion, you can contact him and he'll work with you and figure out how it is you're thinking and how he can redirect your thinking. He's happy to do
I'm
that.
back.
Hey, Jonathan, I was just telling them that you'd be happy if someone knows that they're having an issue, say in the geometry area, up to the end of July, to work with them and help them figure out where they're going wrong in their thinking process, correct?
Yes, yeah, that's not a problem. You're more than welcome to email me and we can set up something. Or you can contact me through Teams. Sorry, my computer froze. I had to actually completely restart my computer, so I apologize. I'm going to have to pull my PowerPoint back up, so give me 1 second. And again, I don't know. This is the first time that my computer's just completely
Jonathan, can I
froze.
ask you a question?
Yes.
Sherry, if I put the materials on MTRP's website, would you be okay with that, or would you rather for me to only send it out? Not the video, just the materials, like the PowerPoint.
That's okay. Yeah, you're more than welcome to share them.
Okay.
Not a problem. Okay, so I'm going to hop back in to my PowerPoint. Now I'm not sharing my screen, so let me share my screen. Almost done. Again, apologize. I know we're running right up on time. Can you all see my screen again?
Yes.
Okay. So so I've given you the again all the tips that we had from the first 2 weeks. So definitely look those back over again. In terms of homework, I definitely recommend you look back over some of the stuff that's on the ETS website, the Praxis Core website. And remember that Khan Academy has put together a free prep course, and you can access that through this ETS website. And so I definitely recommend, the people that are making the test worked with Khan Academy to make the prep course, so you can expect the problems to be really well aligned to what you'll see on the test. And don't forget that there's something called the Praxis Study Companion on the ETS website, where they give you lots of information about the test. We've gone over a lot of stuff here, but it's about 50 pages, I think, of information about the test, practice problems, full solutions, and so there's a lot of good stuff there. Also, I wanted to let you know that you do have the answers to last week's extra exercises, the additional problems at the end of the packet, and I'm also giving you the solutions to the additional problems at the end of this week's packet. So you do have the answers. So if you end up having trouble getting any of these answers, you're more than welcome to email me about them. Remember that Reach, I work for Reach and the Math Resource Center. We are doing tutoring online. So if you needed some help, you're always welcome to reach us online. And hopefully one day soon, we will be back to face-to-face tutoring in the Belknap Academic Building, room 241, and you're always welcome to visit us. A couple of closing thoughts, and then I'll take any last-minute questions that you all have. But one is, you can pass this test. I've had people that have been so frustrated and so down because they've taken the test a couple of times and just really struggled. It is a lot of information. It's a lot of different topics. And so I know it can be very frustrating, but I promise you can pass it. I've had people that tell me that they didn't think there was any way they could ever pass this test. And it took them a couple of times, but they got there. And so please don't give up. Stay positive if you struggle with math. Definitely practice. There's lots of great problems. I've given you a lot of good practice problems to look at. Again, there's videos, Khan Academy problems you can work through on that prep course. There's problems in the Praxis Study Companion. There's lots of good practice problems out there. So do as many practice problems as you can. Make sure you use the stuff that's on the ETS website. Remember, they make the test. You can find some other good online resources. Definitely use Reach. We're here to help you, and we're always on Microsoft Teams. So reach out to me or some of the other people at Reach, and we'll definitely help out. So that's what I have. Thank you all so much for being here. And like I said, I'll hang around for a few minutes for anybody that wants to ask other questions. But otherwise, that's definitely my time, and I appreciate you all for coming.
Thank you again, Jonathan. And also, I
Yes,
just
thank you.
started the link on MTRP's website. I will put it in the group. Give me about 15 minutes before all the files are uploaded. You can access it there, and I'm also going to send it out email as well. Something else I wanted to add, I know right now we're not in the norm of being on campus and being in classes. MTRP does supply practice tests. So going into the fall, I know that the deadline for graduates is different right now from possibly from the undergraduate teacher ed program. So if you want to access some of those virtual codes to take the Praxis test online, I will have them going into the fall. Not during the summer, but I will have them going into the fall because it's easier for me to purchase since we're not on campus at the moment. So if you're interested in just testing and just taking a practice test, I do believe the math is interactive. It'll tell you exactly what you got right and wrong. Not so much for the writing, it's a little bit different, but we do have the writing workshop coming up in July. So if you have not RSVP'd, I'll send out the RSVP link for that if you're interested in attending to that as well. And if you have any questions or need any assistance, feel free to reach out to me directly. And that's pretty much it. And I'll turn it back over to you all so you can ask whatever questions you may have.
So one more thing.
Hands raised, Jonathan. I don't know if they have questions.
Okay, I'll pop over in just a second. One other thing I'll add is if you were with us last week, you may know I only have a few more weeks left at U of L. So if you want to ask me specifically a question, it would probably be best to reach out to me in the next probably 2 weeks. Would be best. Now, having said that, if you reach out to me afterward, you're going to get my out of office message and it'll have my new email address. I will still answer your questions if you contact me. It's not that I won't, but it'll be easiest if you reach out to me probably in the next few weeks if you do have some questions about the math test. Okay, so hands raised. Let me pop over and see if I can see. Looks like Brenda and Letitia, either of you?
My question was for Sherry, but that was fine. I'll just email them. Thank you.
Okay.
Thank you so much for your time.
I'm still on here if you want to ask. It's up to you. I'm still here.
It's just about the writing, to make sure that you send me the material on the writing.
Okay, I will.
Thanks, Sherry.
No problem.
Bye.
I'm still on.
I didn't know my hand was raised. I'm sorry.
Oh, no worries. Any other questions, comments, concerns? Well, thank you all so much. I know you all have given up a lot of time to be here. I hope you found it helpful. Sometimes these workshops, they just kind of give you the tips and they don't really go through problems. But I think there's a lot of value in actually spending some time walking through the problems. If some of them, went over your head right now, don't stress. I mean, you've got time to look over some of that stuff and there's lots of good stuff out there. But I wanted to give you a lot of practice problems so you could see what kind of problems to expect and then kind of put the tips and tricks in the context of the problem so you could see kind of what we're talking about with some of those strategies for solving the problem. So hopefully you found that format helpful. If you have any ideas on how we can make these things better, definitely let Sherry know, because even though I won't be here, somebody else from Reach will be doing future workshops. And so we definitely take your feedback and take it into consideration when we design these things. So. But thank you all so much. Hope you have a great summer, rest of the summer. And like I said, feel free to reach out to me either by email or you're more than welcome to call me through Teams. I'll have it up quite a bit over the next 2 weeks. So feel free to always send me a little chat message on Teams and I can meet with you kind of like this, but one-on-one, or we could talk through email either way. But I'm happy to set up like a little video call, just like we're doing right now, anytime. So just let me know, okay? All right. Have a good one. And Sherry, if you don't have anything else, I'll probably head off here in a minute. Thanks so much for coming.
Thank you again,
Bye-bye.
Jonathan.
You're very welcome. See you, Wanda.
Bye,
Take care.
Jonathan. Bye,
See you, everybody. Have a good one.
Okay, does anybody have anything else they might need assistance with or have any questions about? Okay, I put the form to RSVP. That should send you directly to the RSVP link. Even if you've done it already, go ahead and do it again just to be sure. So if you're interested in attending the writing, it'll be the same format. We'll use Teams. It is interactive. And Dr. Cassie Book will be doing it. She's actually one of the directors over in the Writing Center at U of L. And she does a really good job with the workshop as well. And the reason that we focus on writing and math is because those tend to be the two barriers for students when they get into the program. So reading is a challenge, but not as much as we've seen the need for people to have the writing and the math praxis workshop. So if you have any questions or if you need any other resources, please let me know. All righty. Well, you all have a great weekend.